Okay, so let's take another question. Two particles move in uniform gravitational field with acceleration g. At the initial moment, their velocities are 3 meters per second and 4 meters per second, respectively. And both the particles are initially at the same point. Initially, they are thrown with the respective velocities in horizontally opposite direction. Particle 1, say, is thrown like this. Particle 2 is thrown like this. Find the distance between the particles at the moment their velocities become perpendicular. So as you can see from this diagram, I've made this diagram before because it's a type of a question where the diagram is geometrically important. So I've made this beforehand. So as you can see, as you can make out, that this particle is thrown horizontally with a velocity of 3 meters per second. And this is thrown horizontally with a velocity of 4 meters per second. Both these particles are thrown in horizontally opposite directions. So the trajectory of this particle will be like this. Trajectory of this particle will be like this. Okay. Now we have to find the distance between the particles at the moment when their velocities become perpendicular. So when do the velocity of these particles become perpendicular? In other words, the velocity vectors are forming a 90-degree angle with respect to each other. The velocity vectors of these two particles are forming a 90-degree angle with respect to each other. So if this is the trajectory of this particle and this is the trajectory of this particle, so we can make out from this trajectory that the velocities at any point will always be along the tangent to this particular curve, which is the trajectory at that particular point. So if the particle is say here, if you draw the tangent to this curve at this point, the velocity will be along this tangent. It will be in this direction but along this tangent. So if the particle is going from here to here like this, and say the particle at any point of time is here, then the velocity vector points along this tangent like this. Similarly, if this particle goes like this, and after say time t the particle is here, so the velocity vector points along the tangent like this. This line is the tangent which I have extended myself. This line and this line are the tangents which I have extended myself, just to illustrate that say there is a point of time after which both the particles have their velocity vectors which will make a 90-degree angle with respect to each other. Now suppose after time t they make a 90-degree angle with respect to each other. Okay. Now for particle 1 and for particle 2 also, in fact, we know that the horizontal component is always 3 meters per second. For particle 1, if this is particle 1, the horizontal component of the velocity will always be 3 meters per second, and it will not change because the only acceleration that is there is in the vertically downward direction, that is g, equal to 9.8 meters per second square. Right. Similarly, for this particle, the horizontal component of the velocity will always be the same, and that will be equal to 4 meters per second, because the only acceleration even for this particle is only in the vertically downward direction, because of which the horizontal component of both these particles will always remain constant throughout their motion from this point initially to this point. As this particle travels from this point to this point, its horizontal component will always be equal to 3 meters per second. Similarly, as this particle travels from this point to this point, the horizontal component will always be equal to 4 meters per second. Say for particle, suppose this is particle 1, so we call it P1, and this is particle 2, suppose we call it P2. So for particle 1, horizontal component is always 3. What is the vertical component? We can use the equation V is equal to U plus AT for finding out the vertical component, where all these components are in the vertical direction. So we know that u is in the vertical direction, and in the vertical direction the velocity of this particle 1 is 0. The initial velocity of particle 1 in the vertical direction is 0. Why? Because it is thrown horizontally. So in the vertical direction the initial velocity is 0, the acceleration is g, and time is, say, any time t. So 0 plus gt. So horizontal component is always 3 meters per second. Vertical component will be after time t, where t is any time. After time t, the vertical component we can find out is equal to gt. After time t, the vertical component will be equal to gt. So if this angle is alpha and this angle is beta, what is tan alpha? Vy by Vx, which will be equal to gt by 3. Similarly, what will be tan beta? Vertical component of the velocity of particle 2 divided by the horizontal component. What is the vertical component? Gt, same. Because for this particle 2 also, this equation is exactly similar, because the initial velocity in the vertical direction for particle 2 is also 0. The acceleration also is g, vertical downwards. So after time t, the vertical component of the velocity for particle 2 is also gt. The horizontal component, as I said a few minutes earlier, will be 4. We know the value of tan theta, we know the value of tan beta. We also know that alpha plus beta is equal to 90 degrees. Because if you take a look at this triangle, alpha plus beta will be equal to 90 degrees. Why? Because this is a right angle triangle, right? We know that the velocity vectors will always will at after time t, because initially the assumption is we are saying that after, say, time t, the velocity vectors are perpendicular to each other. Now after time t, we are finding out tan alpha. After time t, we are finding out tan beta, and we know that alpha plus beta is equal to 90 degrees, or pi by 2 radians. Now suppose if there is a right angle triangle, this is alpha, this is beta, this is 90, this is A, this is B. So tan beta is equal to A by B, tan alpha is equal to B by A. So tan beta is equal to 1 by tan alpha, right? Similarly here, tan alpha is equal to 1 by tan beta. So if you use this information and collectively use this information, that tan alpha is equal to 1 by tan beta, what you will get is gt by 3 is equal to 1 by gt by 4. So your gt by 3 will be equal to 4 by gt. So t will be equal to root 12 by g. This will be the value of t. Okay. So the way to solve this question is, we assume that after time t, suppose if the velocities are perpendicular to each other, we have to find the distance between the particles when their velocities are perpendicular. Let us assume that after time t, the velocities are perpendicular. After time t, for particle 1, the horizontal component is always same, 3. After time t, for particle 1, the vertical component is u plus at, which is equal to gt. gt by 3 will be equal to tan of alpha, because the slope of this trajectory is tan alpha, and the slope of this trajectory is also equal to the velocity, direction in which the velocity is pointing, which will be equal to Vy by Vx. Similarly here, tan beta is also equal to the same Vy by Vx of the particle 2. you combine this information, and you will get it this. Now, as far as these particles are concerned, the question that what we have to find out is the distance between the particles at the moment their velocities become perpendicular. So after time this much, what is the horizontal separation between the particles? Horizontal component of both the particles into time. So this particle which will travel a horizontal distance of 3 into this much time. This particle will travel a total horizontal separation of horizontal distance of 4 into this much time. So total horizontal separation between the particles will be this much. Total vertical separation will be equal to 0. Why? Because the vertical displacement of either particles will be given by S is equal to ut plus half a t square. So for both the particles, if the initial velocity in the vertical direction is 0, the acceleration is g in the downward direction, time is any time ct. So for both the particles after time t, the vertical separation is 0, and the vertical displacement traveled by both the particles is the same, because for both the particles, if you use this equation, S will be the same. So the vertical separation between the particles is 0 and the horizontal separation is this. So the total separation between the particles is this.